Hello students, welcome back to our class. In the previous module, we discussed about the concept of probability. And in this module, we are going to discuss a few set of problems given in previous board examinations. Right? So, the very first problem is going to be, see, a card is drawn at random from a well-shuffled pack of 52 playing cards. Well-shuffled pack of 52 cards. So you will have to write the information given in the problem. So what is the information given in the problem? How many number of cards are there? So the total number of cards. So total number of outcomes. Total number of outcomes are going to be, here outcomes are total number of cards, right? So total number of outcomes is equal to 52. Fine. And what is the question here? Find the probability of getting neither a red card nor a queen. Neither a red card. So how many number of red cards are there? So number of red cards is equal to 13 plus 13, which is equal to 26 red cards are there. 26 red cards are there. And out of these 26 red cards, and another thing is, neither a red card, it should not be a red card. It should not be a red card in the sense, absolutely, it should be a black card. Right? And neither a red card nor a queen. Nor a queen means how many number of queens are there totally. So number of queens. Number of queens is going to be, there are totally 4 queens, because in every single set of 13 cards, one queen should be there, right? So therefore, there are totally 4 queens are there. See, out of these 4 queens, there are 2 black queens as well as 2 red queens. Correct? 2 black queens otherwise as well as 2 red queens. But we are removing all the red queens. Removing all the red queens means in these 26 cards, 2 red queens are already there, and 2 red queens plus remaining number of cards is equal to, out of 26, 2 plus 24 is equal to 26. So 2 red queens as well as remaining 24 cards. And here 2 black queens and 2 red queens. 2 red queens are already taken there. So remaining 2 black queens should be removed. So 2 black queens should be removed in the sense what? Number of black cards. Number of black cards without queen. Without queen is equal to, so there are only 2 black queens, so that remaining 26 minus 2 is equal to 24. These are 24 black cards, right? So here 24 black cards are nothing but, those 24 cards are the cards which are not red as well as not queen. Hope you understand. So here, according to the problem, probability of getting neither a red card, we should not get a red card. Neither a red card nor a queen. It should not be a queen also. So you will have to remove all red cards as well as all queens. So how many red cards are there? There are totally 13 plus 13 equal to 26 red cards we are removing. And queens. So totally remaining number of red cards, remaining number of black cards is equal to 26, because already 26 are red cards. So out of this 26, how many queens will be there? There are 2 queens, so that we are removing. So therefore, the total number of cards which are neither red cards nor queens. So therefore, probability of getting neither a red card, neither a red nor a queen, neither a red nor a queen is equal to, considered as probability of getting an event. But before that, we need to write what is the classical definition of probability. That is very, very important, because formula carries half mark also. So that I am writing here the classic definition of probability of getting an event is equal to number of outcomes favorable to E divided by total number of outcomes. Total number of outcomes. So when you see what is the probability of getting an event E, which is equal to number of favorable outcomes is going to be 24. So it would be 24 divided by 52. But you should not leave the problem like that. You will have to convert it into simplest terms. So you keep cancelling. Then you will get like both can be cancelled by 4 if I am not wrong. 4 6 are 24, and then 4 divided by 4 1s are 4, and then 4 3s are 12, which is equal to 6 divided by 13 is the probability of getting this event. You understand? So card is drawn at random from a well shuffled pack of 52 cards. So find the probability of getting neither a red card nor a queen. So it should not be a red card as well as it should not be a queen. So first you will have to remove all the red cards, and then from the remaining cards, means from black cards, again there are 2 queens, so you will have to remove those 2 queens also. Then you will get out of 26 black cards, 2 queens will be there, so remaining 24 black cards which are neither red as well as nor a queen. So the total number of outcomes divided by number of favorable outcomes, whatever the formula is equal to 24 divided by 52. Both can be cancelled by 4. 4 6 are 24 and 4 13s are 52. So 6 by 13 is the probability of getting this event, right? Moving on to the next problem. So here the next problem is two different dice are rolled together. So find the probability of getting a doublet of getting a sum 10 of the numbers on the 2 dice. So there are 2 problems given. For this, definitely we need to frame a table when you are rolling 2 dice. Okay, so I'm just rolling here. The first die has 1, 2, 3, 4, 5, 6, and second die is 1, 2, 3, 4, 5, 6. Okay, see now the possible outcomes that I am writing here. The possible outcomes are going to be 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6. Okay, like that with 2, with 3, with 4, with 5, with 6 as well as we can write. With 2, I can write 2, 1, 2, 2, 2, 3 and so on. With 3, 3, 1, with 4, 4, 1, with 5, 5, 1, with 6, 6, 1. And similarly, the last one also of course we can identify. But here the problem is, first thing is the total number of outcomes. What is the total number of outcomes when you are rolling 2 dice? I am going to write that. Okay, so total number of outcomes is equal to, when you are rolling 2 dice, so that would be 6 square is equal to 36. So these are all 36 number of outcomes. So for the first problem, and I would write the definition of probability of getting an event. Probability of getting an event is equal to number of outcomes favorable, number of outcomes favorable to E divided by total number of outcomes. So that I am going to answer the first problem by identifying what are all the favorable outcomes as per the first information. So what is the first information? Find the probability of getting a doublet. So what do you mean by doublet? 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. So they are called doublets. So doublets will be in this diagonal. Okay, so these are all, there are totally 6 number of doublets, so that according to the first problem, probability of getting an event E1 for example is equal to, there are totally 6 number of doublets, so that 6 divided by total number of outcomes equal to 36, 6 by 36 equal to 1 by 6. As simple as that. And what is the second one? Second one is probability of getting an event. That event is going to be of getting a sum of 10 of the numbers on the 2 dice. So sum of 10 of the numbers on the 2 dice. See here, we have dice already. These are all the possibilities. Out of all these possibilities, you see the first number as well as second number of one particular ordered pair. and wherever you get the sum is equal to 10, sum of both the numbers is equal to 10, you will have to consider those objects. Sorry, consider those, whatever the possibilities. So when you consider those possibilities, if you want to get sum is equal to 10, what could be the possible numbers? Of course, you can definitely observe from this table, but in general, when you think logically, then the sum is equal to 10. Sum is equal to 10 means what? Most probably, I can understand one thing, that 5 comma 5, then the sum is going to be 10. And then 6 comma 4, the sum is going to be 10. And then like 5 comma 5 and 6 comma 4, is there any other sum is going to be 10? 6 comma 4, and of course 4 comma 6 also the sum is going to be 10. And 5 comma 5, if you take any number which is less than 5, then either it should be 4. 4 plus 6 is equal to 10, we already recorded. And suppose the number with 4 already recorded, because 4 comma 6 and 6 comma 4. Suppose with the number 3. With the number 3 we cannot record anything, because 3 plus 7 is equal to 10, but 7 is not there. So 3 comma 7 and 7 comma 3 will not be available. And with number 2, 2 comma 8, 8 is also not available. So the numbers 3 and below, there is no possible outcome available whose sum is equal to 10. So what are the possible outcomes here? The possible outcomes are favorable outcomes. I am talking about favorable outcomes. They are 5 comma 5 is only 1, because 5 comma 5 and 5 comma 5 both are same. So there is only one 5 comma 5 and 6 comma 4 and 4 comma 6. Is there any other favorable outcome whose sum is equal to 10? There is no such. So therefore, the total number of favorable outcomes is going to be 1, 2, 3, whose sum is equal to 10. Therefore, 3 divided by 36. 3 divided by 36 equal to 3 ones are 3, 3 ones and 3 twos are 6. So therefore, 1 divided by 12 is the possibility or the probability of getting an event, whose sum is equal to 10 of the numbers on both the dice. Hope you understand. Right. So this way you can answer these problems. Moving on to the next problem. Here the next problem given, find the probability that a leap year selected at random will contain 53 Sundays. What do you mean by leap year? Leap year has how many number of days? So leap year has 365 days, right? A leap year contains how many number of days? Leap year contains 366 days. So out of 366 days, when you divide that 366 into weeks, how many number of weeks will be there? A week has 7 days. So then it would be 7 times, how much is equal to 360, otherwise the number nearer to 66. 7 into 52 is equal to 7 2s are 14, 7 5s are 35 plus 1 36. So 364 days has 52 weeks, but we have 366 days. So how many days are remaining? So that you can write 366 as 364 plus 2 days remaining. 2 days remaining. See, it means 366 means there are 52 weeks. 52 weeks and there are only remaining 2 days. Okay. So every leap year has 52 weeks. So in every single week, definitely there is a Sunday, there is a Monday, there is a Wednesday, there is a Tuesday, there is a Saturday, right? In every single week. So it means in this particular area, we can get every single week has there is a Sunday. Every single week there is a Sunday. So what does it mean? The remaining 2 days are there. The remaining 2 days are 2 consecutive days. So what are those 2 consecutive days? Those 2 consecutive days are, because there are 2 days, right? 2 consecutive days are, let us start with Sunday. Sunday as well as Monday. These 2 are 2 consecutive days. Otherwise, Monday and Tuesday. Otherwise, Tuesday and Thursday. Monday, Tuesday, sorry, next Wednesday, and after Wednesday, Wednesday as well as Thursday, and Thursday as well as Friday, and Friday as well as Saturday, and Saturday as well as Sunday, right? So these are only the possibilities. How many possibilities are there? See, this is first possibility, second, and this is third, and this is 4, and this is 5, 6, 7. So there are only 7 possibilities. Out of how many days? There are only 2 days remaining. So that the probability of getting an event, what is that event here? That event is getting 53 Sundays. Already 52 Sundays are there. Remaining 1 Sunday is there, right? So that 1 Sunday would be either in this part or in this part, or out of these seven possibilities. Definitely there are 2 days remaining. So those 2 days will be either these 2 days or these 2 days or these 2 days. So that is why the probability of getting 53 Sundays, the number of days remaining is 2, and the total number of possibilities is equal to 7. So 2 divided by 7 is the probability of getting a probability that a leap year selected random will be 53 Sundays. You understand? So already 52 weeks has Sunday compulsorily. So remaining week is nothing but remaining 2 days. So those 2 days can be these possibilities. Out of how many possibilities? There are totally 7 possibilities. So here Sunday will come and here also Sunday will come. Therefore there are 2 remaining days. Therefore 2 divided by 7 will be the probability of getting Sunday like 53 Sundays in a leap year. So please do remember, this is one of the interesting and important problem also, right? And of course I did not write the formula here. You will have to write the formula compulsorily. And moving on to the next problem, find the probability that a non-leap year selected at random will contain 53 Sundays. Just now we discussed about this. There are totally 52 weeks, because a non-leap year contains how many number of days? Non-leap year contains 365 days. So it is 364 weeks, 364 days. There are 52 weeks, and this is 365. Then what is the number remaining? There is only 1 day. So that 1 day can be either Sunday or Monday or Tuesday or Wednesday or Thursday or Friday or Saturday. Again, there are 7 possible number of outcomes. So therefore, probability of getting an event is equal to, you can write this 365 days as 365 is equal to 52 into 7 plus 1. So we are talking about this only 1 day. Therefore, probability of getting this event is equal to 1 out of 7. As simple as that. Okay, right. So moving on to the next problem. Here the next problem is, an integer is chosen random between 1 to 100, between 1 and 100. Between 1 and 100 in the sense what? 1 and 100 will not be included, right? You will have to remember that. See here, random between 1 and 100. Between 1 and 100 means you will not be including 1 as well as 100. So therefore, what is the total number of outcomes? Total number of means total number of possible outcomes. Total number of possible outcomes is equal to, there are total 100. Out of 100 numbers, we are not including 1 and 100. So which is equal to 98 only. So 98 integers. 98 integers from which number to which number? From 2 to 99. From 2 to 99. So find the probability that it is divisible by 8. So what are the numbers divisible by 8? The numbers divisible by 8. Numbers divisible by 8. So what are the numbers divisible by 8? What is the very first number divisible by 8? Of course 8 is the first number, because we have to take the numbers from 2 to 99 only. Now, if you want to take the numbers divisible by 8, you simply take the numbers which are the multiples of 8. Okay, 8 ones are 8, 8 twos are 16, next 8 threes are 24, and so on. 8 nines are how much? 8 nines are 72, and 8 tens are 80, and 8 elevens are 88. And see, we have up to 99, right? 8 elevens and 8 twelves are how much? 96, and 8 13s. 8 13s is not a number which is the number below 100. So 8 12s. 8 12s are how much? 96. So 96 is the last number which is divisible by 8. So which number is this and how many numbers are there totally? It is very easy to identify. So there are totally 12 numbers. Okay. So numbers divisible by 8, these are all the numbers. So therefore, what is the number of favorable outcomes? Number of favorable outcomes is equal to, according to the first problem, the number of favorable outcomes is equal to, there are totally 12 favorable outcomes. How many number of outcomes are there? Therefore 98 outcomes. Therefore probability of getting an event is equal to number of favorable outcomes is equal to 12 divided by total number of outcomes is equal to 98. So when you simplify this, 2 6 are 12 divided by, and 2 4s are 8, 2 9s are 18. So that 6 divided by 49 is the probability that it will be divisible by 8. Probability that it will be divisible by 8. And what is the second one here? Second one given is not divisible by 8. Probability of a number divisible by 8 is 6 by 49. Then probability of number which is not divisible by 8 is its complementary event. So how do you find its complementary event? 1 minus probability of getting an event, which is going to be 1 minus 6 divided by 49, which is going to be 49 minus 6 divided by 49. What is 49 minus 6, which is equal to 43 divided by 49, is the probability of a number which is not divisible by 8. So this way we can easily answer this problem. And moving on to the next problem, see here, 3 different coins are tossed together. Find the probability of getting exactly 2 heads, at least 2 heads. So when you are tossing 3 different coins, see, I am taking 3 different coins here, first coin, second coin, as well as third coin. And in order to find the outcomes, first of all, what is the total number of outcomes? See here, total number of outcomes when you are tossing 3 coins. Total number of outcomes. Total number of outcomes is equal to, we already discussed about this, that a coin has 2 possible outcomes. 2 power, the number of coins is equal to 3, so 2 power 3 is equal to 8. See, it is very easy to list out all the outcomes. There are totally 8 outcomes, right? For the first coin, you can take half of them are heads and half of them are tails. Out of 8, half means 4 of them are heads and 4 of them are tails. I would write that heads, 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 heads. Similarly, tails, 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 tails. And for the second one, half of that means half of 4 is equal to 2. So 2 heads and then 2 tails, and then 2 heads and then 2 tails, right? And for third coin, half of that previous half is nothing but half of 4 is equal to 2 for second one. Half of 2 is equal to 1 is for third one. Means what? Alternate heads and tails. So heads, tails, heads, tails, heads, tails, heads, tails. So this way we can easily list out all the possible outcomes. In the same way, we can list out all the possible outcomes. See, according to the first information, what is that? Probability of getting exactly 2 heads. Number of outcomes gives exactly exactly 2 heads. Exactly 2 heads is equal. Exactly 2 heads. Understand? It should not be more than 2 heads or it should not be less than 2 heads. Exactly 2 heads. Where can you find exactly 2 heads? See, head, head. Exactly 2 heads are there in this. And here also you have exactly 2 heads. No. And here also you have exactly 2 heads. Here not, here not, here not. So, exactly 2 heads can be identified in this particular event as well as in this particular event. Here no. Here exactly 2 heads. There is no. So, exactly 2 heads appear in 3 events. Right? Therefore, probability of getting an event is equal to number of favorable outcomes is equal to 3 divided by total number of outcomes is equal to 8. So, 3 divided by 8 gives the number of outcomes gives exactly 2 heads. So, exactly 2 heads appears in 3 events. And coming to the second one. What is the second one? Here the second one is the probability of getting at least 2 heads. So, number of outcomes gives at least 2 heads. At least 2 heads. What do you mean by at least 2 heads? At least 2 heads means 2 are more than 2 heads, but should not be less than 2 heads. So, where you can find at least 2 heads? See here, at least 2 heads, and here at least 2 heads, because there are 3 heads means more than 2, and here also 2 heads, at least 2 heads. Here only one head we should not consider. Here we should consider at least 2 heads. Here one head, here one head, here one head. So that at least 2 heads means 2 are more than 2 heads. Already 2 heads with 3 events and one more is with 3 heads. So there are totally 4 number of favorable outcomes. Therefore, what is the probability of getting an event which has more than 2 heads, otherwise at least 2 heads, is equal to 4. So 4 divided by 8, which is going to be 1 divided by 2. So this way we can easily figure out the number of possible outcomes, otherwise the number of favorable outcomes, by listing out all these items. Okay, right. So moving on to the next problem. Here the next problem is cards marked with numbers 3, 4, 5 and so on up to 50. So how many number of cards are there? Now I am going to write. So total number of cards, otherwise total number of outcomes. Total number of outcomes are nothing but total number of cards are going to be up to 50, but 1 and 2 are not there. So 50 minus 2 is equal to 48 number of cards are there. So those numbers are 3, 4, 5 and so on up to 50. Okay, fine. Are placed in a box and mixed thoroughly. A card is drawn at random from the box. Find the probability that the card selected bears a perfect square number. So what do you mean by perfect square number? Perfect square number is nothing but 1 into 1, 2 into 2, 3 into 3, 4 into 4. These are perfect square numbers. So what are number of perfect square numbers? Number of perfect square numbers. Now I am going to list out all these perfect square numbers. So when I am listing out all these perfect square numbers, 1 square is equal to 1 is not there. So 2 square is equal to 4 is there. And 3 square is equal to 9. 4 square is equal to 16. 5 square is equal to 25. 6 square is equal to 36. 7 square is equal to 49. 8 square is equal to 64, but 64 is not there. Therefore, we should consider only up to 49. Therefore, how many number of square numbers are there? 1, 2, 3, 4, 5, 6. So, number of perfect square numbers is equal to 6. Therefore, probability of getting an event is equal to number of favorable outcomes divided by total number of outcomes. So, number of favorable outcomes is equal to 6. Total number of outcomes is equal to 48. So what is 6 divided by 48? 1 divided by 8. 1 divided by 8 is the probability of getting this event. Of course, it's quite simpler, but you need to identify how many number of square numbers are there. Next, coming to the next problem. See here, a number x is selected at random from the numbers 1, 2, 3 and 4. So, x is selected from the numbers 1, 2, 3, 4. And y is selected from the numbers 1, 4, 9, 16. Y selected from the numbers 1, 4, 9, 16. So, find the probability that the product of the numbers x and y is less than 16. See here, what is the total number of outcomes? The total number of outcomes are nothing but these are 4 numbers and these are 4 numbers. So, 4 times 4 is equal to 16. Okay. So, number of possible outcomes. Number of possible outcomes. Number of possible outcomes are nothing but 16. How can you say that it is 16? I will show you this. First 1, 2, 3, 4 numbers and the next numbers are 1, 4, 9, 16. Okay. So here according to the information, the product, see here the product. So I am going to find the product. The product is going to be 1 into 1 equal to 1. Okay. So 1 1s are 1, 1 2s are 2, 1 3s are 3, 1 4s are 4. Now with 4, 4 1s are 4, 4 2s are 8, 4 3s are 12, 4 4s are 16. With 9, 9 1s are 9 and 9 2s are 18 and 9 3s are 27 and 9 4s are 36. With 16, 16 1s are 16, 16 2s are 32, 16 3s are 48, 16 4s are 64. So if you count everything, then you will get totally 16 number of outcomes. So what about the number of favorable outcomes? Number of favorable outcomes according to the given information or according to the given condition is product is less than 16. Product is less than 16 means 16 will not be included. Less than 16. See, identify the numbers which are less than 16. See here, first number, second number, third number, fourth number, fifth number, sixth number, seventh number. You should not consider this. Okay. So there are totally 1, 2, 3, 4, 5, 6, 7, 8. There is no other product which is less than 16. So therefore, how many number of favorable outcomes are there? 1, 2, 3, 4, 5, 6, 7, 8. So favorable outcomes equal to 8. What does it mean? There are totally 8 numbers whose product is equal to less than 16. So therefore, probability of getting an event is equal to number of outcomes favorable to the event E, that is 8, and the total number of outcomes equal to 16. 8 by 16 is equal to 1 by 2. So this way we can easily answer this problem. Hope you understand. Right. So coming to the next problem here. In a single throw of a pair of dice, we already discussed when you are rolling a die 2 times, otherwise rolling 2 dice at a time, the result remains unchanged. Means the resultant outcomes remains unchanged. A single throw of a pair of dice when you are rolling 2 dice. So what is the probability of getting a prime number on each dice and a total of 9 or 11? Okay. So for this you need to definitely now make a table with all the outcomes. Okay. So the outcomes are here 1, 2, 3, 4, 5, 6 are the numbers on the dice. Here 1, 2, 3, 4, 5, 6. So better you make this list and then keep it ready so that you can directly answer that. Okay. So here 1 comma 1 and here 1 comma 2 and 1 comma 3, 1 comma 4, 1 comma 5, 1 comma 6 and 2 comma 1, 2 comma 2, 2 comma 3, 2 comma 4, 2 comma 5, 2 comma 6. So similarly we have 6 comma 1, 6 comma 2, 6 comma 3, 6 comma 4, 6 comma 5 and then 6 comma 6. So there are totally 36 number of outcomes. So I am going to write that total number of outcomes. So number of possible outcomes. Number of possible outcomes is going to be 36. Now coming to the first problem. What about the number of favorable outcomes in the first condition? Number of favorable outcomes is going to be, according to the first case, what is the first condition here? A prime number on each dice. So what are prime numbers out of this 1 to 6 numbers? 2 is a prime number, 3 is a prime number, 4 is a prime number, 5 is a prime number, and of course 6 is not a prime number. So 2, 3, 5 are primes, and here also 2, 3, 5 are primes. So here you can understand one thing, 2 comma 2 is a prime, 2 comma 3 is a prime, and 2 comma 5 is a prime. So these three are primes, okay, with the combinations of 2. Now with the combinations of 3, 3 comma 2 is a prime, and 3 comma 3 is a prime, and 3 comma 5 is also a prime, because both must be primes, okay. And with 5 comma 2 is a prime, and 5 comma 3 is a prime, as well as 5 comma 5 is also a prime. So therefore totally how many number of primes are there on both the dice? 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are totally 9 favorable outcomes, saying that prime on each dice. Therefore, what about the probability of getting an event, which is equal to number of favorable outcomes divided by total number of outcomes. So 9 divided by 36 is equal to 1 divided by 4. So 1 divided by 4 is the probability of getting a prime number on both the dice. Okay, so that's the first one. And what is the second condition given here? Second condition is a total of 9, otherwise 11. Total of 9. So how do you get total of 9 here? To get the total of 9, first of all, 9. If you want to get the total of 9, let us start with 6. Okay, so 6 comma 3 is one outcome, and of course 3 comma 6 is also one outcome. And with 5, so 5 comma 4 is one outcome, as well as 4 comma 5 is also one outcome. With 4, of course 4 comma 5, 5 comma 4. With 3, 3 comma 6, 6 comma 3 is also over. With 2, 2 plus 7 is equal to 9. So 7 is not there. So that these 4 are the possible outcomes whose sum is equal to 9. And then second one is R11. Coming to 11, then if you want to get 11 as the sum, let us start with 6. 6 comma 5 is 11, and of course 5 comma 6 is also 11. And then with 5, of course 5 already used. With 4, 4 comma 7 is equal to 11. So those numbers will not come. Therefore 6 comma 5 and 5 comma 6 satisfies the given condition. But what is the problem? A total of 9 or 11. 9 or 11 means these outcomes will come, as well as these outcomes also will come under consideration. So therefore, how many number of outcomes are there? 1, 2, 3, 4, 5, 6. So therefore, a total of 9 or 11. Total of 9 or 11, that is number of favorable outcomes according to the second condition. Number of favorable outcomes is going to be how many? These are 4 plus 2 is equal to 6. So therefore, probability of getting an event is equal to number of favorable outcomes divided by total number of outcomes. So 6, 1, 6, 6 are 36. This is what the way to answer the problem. Hope you understand. And moving on to the next problem. Here the next problem is a bag contains 15 white and some black marbles or black balls. If the probability of drawing a black ball from the bag is thrice that of drawing a white ball, find the number of black balls in the bag. See, for example, this is a bag. Okay, so this bag contains how many number of, a bag contains 15 white balls. So white balls are 15. Okay, and some black balls. I do not know how many number of black balls are there. So the number of black balls is equal to X. From this information, we can say that the total number of balls is equal to 15 plus X, because 15 white balls are there and X black balls are there. If the probability of drawing a black ball, so according to the given problem, probability of getting a black ball is from the bag is thrice. Thrice is nothing but 3 times that of probability of getting a white ball. So probability of getting a white ball. So you will have to utilize this information. What is probability of getting a black ball? How many black balls are there? X black balls are there. So probability of getting black ball is number of black balls divided by total number of balls is equal to 15 plus X is equal to 3 times probability of getting a white ball. Probability of getting a white ball is 15. So 15 divided by, of course, total number of balls is equal to 15 plus X. Right? It is very easy to simplify this because 15 plus X gets cancelled because that is a single denominator, and then the numerator is X is equal to 15 into 3 is equal to 45. So what do you mean by this? The total number of black balls is going to be 45. Find the number of black balls in the bag is equal to 45. So this way we can easily answer the problem. So moving on to the next one. A game of chance consists of spinning an arrow which comes to rest pointing at one of the numbers 1, 2, 3, 4, 5, 6, 7, 8, of course in the figure, and these are equally likely outcomes. And what is the probability that it will point at 8? See how many numbers are there totally? There are 8 numbers. So with this we can understand number of possible outcomes. Number of possible outcomes is equal to 8 because there are 8 numbers. Coming to the first one, what is the probability that it will point at 8? How many number of 8s are there? There is only one 8. So probability of getting an event is equal to 1 divided by 8. What is this 1 there? There is only one 8. That 1 divided by 8 is equal to probability of 8 is equal to total number of outcomes. And coming to the second one, an odd number. How many odd numbers are there? See, 1 is an odd number, 3 is an odd number, 5 is an odd number, 7 is an odd number. So out of 8, half of them are even, half of them are odd. So there are totally 1, 2, 3, 4 number of odd numbers. So that probability of getting an event is equal to 4 divided by 8, which is equal to 1 divided by 2. So the number of odd numbers is also equal to the number of even numbers in this condition. A number greater than 2. A number greater than 2 means 2 should not be included. The number greater than 2 means how many numbers are there totally? There are totally 8 numbers. The number greater than 2 means all these numbers. 1 and 2 will be excluded. So there are 6 numbers which are numbers greater than 2. Therefore 6 divided by 8, which is equal to 3 divided by 4. Right? The number greater than 2. And a number less than 9. A number less than 9 in the sense, how many numbers are there totally? The total number of numbers is equal to 8, and every single number is less than 9 only, no? Every single number is less than 9 only. So therefore 8 divided by 8, which is equal to 1. So this way we can find out the probability in different cases. And moving on to the next problem. So two customers, Shyam and Ekta, are visiting a particular shop in the same week, Tuesday to Saturday. Okay? Tuesday to Saturday, Tuesday, Wednesday, Thursday, Friday and Saturday. Here also Tuesday, Wednesday, Thursday, Friday and Saturday. See, these are 1, 2, 3, 4, 5. 5 times 5 is equal to totally 25 number of outcomes are there. I am going to write the number of outcomes. So number of possible outcomes. Number of possible outcomes is equal to 25. Now coming to the problem. So what is the problem here? Each is equally likely outcome to visit whatever it is. What is the probability that on the same day? What do you mean by same day? Tuesday, Tuesday, Wednesday, Wednesday, Thursday, Thursday, Friday, Friday, Saturday, Saturday. Means they will come in this diagonal. Okay? The same day. Tuesday, Tuesday, Wednesday, Wednesday, Thursday, Thursday, Friday, Friday, Saturday, Saturday. On the same day is going to be probability of getting an event. Means on the same day there are 1, 2, 3, 4, 5. So that 5 out of 25, which is equal to 1 divided by 5. That is the probability that they both go for shopping on the same day. And what is second one? Consecutive days. Consecutive days means what? Tuesday, Wednesday, Wednesday, Tuesday. Both come under consecutive days. And Wednesday, Thursday, and Thursday, Wednesday will also come. And then Friday, Thursday, Friday, and Friday, Thursday will also come under consideration. And then Saturday, Friday, and Friday, Saturday will also come under consideration. So therefore, how many number of days which are consecutive? So consecutive days are 1, 2, 3, 4, 5, 6, 7, 8. So probability of getting an event is equal to 8 divided by 25. That is on consecutive days. So coming to the third one, what is the third one here? Third one is different days. Different days are nothing but which are not same days. So already we discussed about the same days. Same days is equal to 1 by 5. So different days is equal to 1 minus 1 by 5, which is going to be 4 by 5. See how simple it is. So this way we can answer the problem easily. And moving on to the next one, a bag contains 5 red balls and some blue balls. Just now we discussed this kind of problem. For example, this is a bag, okay? So in this bag contains 5 red balls. So how many number of red balls are there? Red balls are 5. And some blue balls. We do not know how many number of blue balls are there. So blue balls are X. So what is the total number of balls in this bag? Total number of balls is equal to 5 plus X. And what is the condition given here? If the probability of drawing a blue ball, so according to the given problem, probability of drawing a blue ball, so probability of drawing a blue ball is double that of 2 times of a red ball. So probability of drawing a red ball. So determine the number of blue balls in the bag. So in order to find out probability of getting a blue ball, the number of blue balls is equal to X divided by total number of balls is equal to 5 plus X is equal to 2 times probability of drawing a red ball is 5 divided by total number of balls equal to 5 plus X. And similarly, 5 plus X is a single denominator in both the fractions, can be cancelled, and then X is equal to 2 times 5 is equal to 10. Therefore, the total number of blue balls in the bag is going to be 10. So this way we can answer the problem. And moving on to the next, a box contains 12 balls, out of X are black. See, again there is a box, okay, otherwise bag, whatever it is. A box contains 12 balls. So the total number of balls is equal to 12. 12 balls, out of which X are black balls. So the number of black balls is equal to X. If one ball is drawn at random from the box, what is the probability that it will be a black ball? So according to the given problem, probability of getting a black ball in this first case is equal to X upon 12. Probability of getting a black ball is equal to X upon 12. That is the first one. And what is the second one? See, second condition given here is if 6 more black balls are put in the box. Again, black balls are put in the box are 6. Now in the second case, the total number of balls will become 12 plus 6 is equal to, now total number of balls equal to 18. Okay, because you are putting 6 more black balls. So the total number of balls is equal to 18. If 6 more black balls are put in the box, the probability of drawing a black ball now is, so probability of drawing a black ball, so this is second case for example, is double of what it was before. So 2 times probability of drawing a black ball in the first case. Okay. So now probability of drawing a black ball in the second case, total number of black balls is going to be how much? X plus 6 is equal to X plus 6 divided by total number of balls in the bag is equal to 18 is 2 times probability of drawing a black ball in the first case is going to be X divided by 12. Now you need to simplify this. This is 2 1s and 2 6 are 12 and 6 1 6 3s are 18. By cross multiplication, X plus 6 is equal to 3 into X is equal to 3X. Okay. So transpose X that side. So 6 is equal to 3X minus X is equal to 2X. Therefore, X is equal to 2 3s are 6. So what does it mean? It means initially there are 3 black balls in the box. Okay, right. So next, what is the next problem? So the next problem is going to be a jar contains 24 marbles. Some are green and other are blue. So this is also same as like, so this is a jar for example. Okay, so in this jar we have 24 marbles. So the total number of marbles is equal to 24 marbles. Some are green and others are blue. So for example, green marbles are for example X, and then the other marbles are blue. What about the blue marbles out of 24? So 24 minus X are blue marbles. If a marble is drawn at random from the jar, the probability that it is green. So probability of drawing a green marble is going to be 2 divided by 3. So find the number of blue balls, otherwise the number of blue marbles in this. See, probability of drawing a green marble, there are green X marbles divided by out of 24 is equal to 2 divided by 3. So that 3 1s, 3 8s are 24. By cross multiplication you get X is equal to 8 2s are 16. Means what? The number of green marbles is equal to 16. So number of green marbles is equal to 16, and the number of blue marbles is equal to how much? Blue marbles is 24 minus X, means 24 minus 16 is equal to 8. So find the number of blue is equal to, which is going to be 8 marbles. So this is also just similar to the previous problem, and this is what is exactly the problems, the number of problems given in previous board examinations. Of course, all these problems are quite simpler, that you need to understand what is the situation given in the problem. And it is mandatory to write the formula, that there is only one formula, right? There is only one formula, that is probability of getting an event equal to the number of favorable events, otherwise the number of events favorable to E divided by the total number of events, gives you, the formula that it carries minimum half mark. And whatever the information given in the problem, I just drew a figure for you to get a clear cut idea. So this pictorial representation is also sometimes gives you a chance to get better marks. So that this is very simple topic and interesting topic. So please do concentrate and practice as many problems as you can which were given in previous board examinations. So hopes you, I think helps you getting better marks in upcoming board examinations. Hope you understand and enjoy the class. Thank you.